real exam questions. This is question 67, and it's about beam design. Determine the bending moment capacity in ultimate limit state accidental of a rectangular concrete cross-section with the following characteristics. The depth of the beam is 600 millimeters, the width 400 millimeters. The tension reinforcement is in one layer and consists of 3 diameters 16 and 2 diameters 25. The contribution of the compression reinforcement can be ignored. The concrete quality is 45 megapascal and the yield strength of the reinforcement is 500 megapascal. The stirrup diameter is 8 millimeters and the concrete cover is 40 millimeters. We start by calculating the total amount of tension reinforcement, which is 3 diameters 16 plus 2 diameters 25. It gives you 603 plus 982. It's 1,585 square millimeters. D1, the point of gravity of the reinforcement. When we start at the most tensioned fiber of the beam, then we have here a tension reinforcement. Then you can see that we have the 3 diameter 16. The 3 diameter 16 is the 603 with its distance to the most tensioned fiber, which is 8 for the stirrup, 40 for the concrete cover, and then point of gravity for this bar of 16. We add to that the 2 diameters 25 on the same matter. So this is 982 for the 2 bars, plus the lever arm, which is of course the stirrup 8 plus the concrete cover plus half the diameter of the reinforcement. And you divide this by the total amount of reinforcement. So the lever arm of AS1 is then equal to 59 millimeters from there to there. Then the effective depth is the total depth minus the lever arm, D1, and gives you 541 millimeters. The design value of the yield strength FYD is then equal to 500 divided by 1 because we are in ultimate limit state accidental. So it's not 1.15 but 1. So this is 500 megapascal. The design value of the compressive strength of the concrete is alpha cc times fck over gamma c. Alpha cc is 0.85. The fck was concrete quality was 45 megapascal. The material factor is 1.2 because we are now in ultimate limit state accidental. So the design value of the compressive strength is then 31.9 megapascal. The mechanical reinforcement ratio, omega, is equal to the reinforcement times the yield strength of the steel divided by the cross section minus the compressive stress of the concrete. So we have then 1585 times FYD was 500, FCD was 31.875, and the width was 400, and the effective depth was 541. So omega equals 0.11. Now we use the concrete tables, and for omega equals to 0.11489, we look up in the table, and you will see that this must be between those two values, just between those two. It also means that the steel has yielded, and you see that we are in the domain 1b because the epsilon s is maximum and the epsilon c, the strain of the concrete is less than 3.5. So it's only in domain 1b like that. We make an interpolation for omega to find mu d, the reduced bending moment. Of course, this is classic way of doing it. And we have 1.1074. And with this reduced bending moment and with the definitions of the mu d, we can directly calculate what is the resistance bending moment, and it will be 401 kilonewton meter.